This video, we're going to take a look at slope and the rate of change and how that relates to slope-intercept form. And then we'll look at comparing parallel and perpendicular lines and how slope is affected by those two. And then we'll look at an application to this. So let's start off with slope. Slope is really important. Slope is notated as the letter M, where M is your rise over your run. So the slope indicates the change in the y. So rise is your change in the y value, so your change in vertical distance, your rise, how much you're going up or down. Then your run is your left to right movement. So typically we look at this as the rise being your up and down, and then your run being your right to left movement. So if you have slope, if you have a fraction or slope or just any value, if the top number is positive, that means we go up. If the top number is negative, that means we go down. If the bottom number is positive, that means we go right. If the bottom number is negative, that means we go left. So based on that fraction that you create when you identify slope, it's positive 2 over 3, means you go up 2 to the right 3, positive 2 over a positive 3, up and to the right. So that's your slope, your rise over run. We have a slope formula that we're going to define here. The slope formula is y2 minus y1 divided by x2 minus x1. y2 minus y1, think about that. y2 minus y1 is the change in vertical distance. I'm just going to throw 2 points on this graph over here. Just kind of show you. I'm going to erase this also maybe. So if I have like a line, and I'm trying to calculate the slope between these 2 points. So this point and this point, I'm trying to calculate the slope between these 2 points. My change in y value, this would be my y2. So if this is my x2, y2, and this is my x1, y1, so that's just the first order pair, that's the second order pair. If I do y2 minus y1, that will tell me this vertical distance change. How many units am I going up from y1 to the y2? And then on the same concept with that, if I do x2 minus x1, that will tell me my horizontal change. So my distance from here to here. So then when I create a fraction with it, that will tell me the slope. So the y2 minus y1 tells me that vertical change. x2 minus x1 tells me that horizontal change. And there's a lot more we could talk about with slope, but as we go through this video here, we'll just define more pieces of slope. But let's go ahead and just start finding slope. So we have number 1, find the slope of the line through the point -2, 3, and 1, -6. So when you're trying to find slope between 2 points, there's a couple different ways that you could do this. So actually, let me go get back to this graph here, and let me erase this. I'm going to use these same 2 points. Another way of doing this, as I was just talking about with rise over run being your up and down over your right to left, you could also, let's clean this up a little bit. All right, you could also go up however many units. So that would be the vertical change, you're up. And then you go over to however many units. So you would go right with this example that I just threw up here. So up means positive, right means positive. So then you'd create a fraction, whatever amount of numbers you went up, whatever amount of units you went right, that would be your slope. So that's one way of doing it. You could plot the points on a graph and then calculate it that way by counting the units. I want to stick with the slope formula though, because that's going to be more useful in applications and just different scenarios that we'll see. So let's use the slope formula. I want to find the slope between these 2 points. This is my x1, this is my y1, this is my x2, and this is my y2. And it doesn't matter which one you call your 1s and your 2s. You just got to label the order pair. Like you can't do it as x1, x2. Like that's not appropriate labeling. The labeling is xy because order pairs are xy. So that's why I'm doing x1, y1, x2, y2. So the slope formula is y2 minus y1 over x2 minus x1. So I'm going to take the y2, which we identified as -6, minus the y1 of 3 over the x2 of 1 minus the x1 of -2. So notice how I wrote that part? Minus -2. The slope formula is x2 minus x1. So this is your x2 minus your x1. So the -2 is the x1. Don't look at this and say, well, x1 is -2, so I'm just going to write this as 1 minus 2 because it's already minus. No, it's minus a -2 there. So it's a really, really easy mistake to make there. Now let's subtract the top. -6 minus 3 is -9 over 1 minus a -2. That's going to become 1 plus 2, because minus a -2 is 1 plus 2, that's 3. So we get negative 3. Our slope then is negative 3. And if you wanted to see, like, well, how would that translate to an actual graph? This would be negative 3 over 1, technically. Negative 3 over 1. So that means you would go down 3, because the top number is negative, and to the right 1. So you go down 3 and to the right 1. With negatives, so if I have like negative 3, people kind of get confused of like, where do I put that negative? Do I put it with the top? Do I put it with the bottom? It doesn't matter where you put the negative, just as long as you don't do this. Like, don't put the negative with both top and bottom, because if you put the negative with both top and bottom, you've then created a positive fraction, or a positive value, positive slope. We don't want that. We have a negative slope. We have the slope of negative 3, so our slope needs to stay negative. So you could put it as negative 3 over 1. You could do it as negative 3 over 1, or 3 over negative 1. Doesn't matter. Just one of those terms needs the negative. And if you wanted to, you could go ahead and plot these 2 points. So maybe I'll just show this one time. Negative 2, 3 is here, and then 1, negative 6 is here. So calculating slope just by actually counting values, maybe I'll just do this one time. If I'm going from point to point, from here to the other point, so I'd go down 1, 2, 3, 4, 5, 6, 7, 8, 9. I went down 9 units, so that'd be negative 9. And then I went to the right 1, 2, 3 units, so that'd be negative 9 over 3, and that simplifies down to negative 3. So we get the exact same answer, just showing you there's multiple ways of getting slope. But I'm going to use the slope formula, though, moving forward. It's more useful. Okay, next one, number 2. So same thing, we want to find the slope. So m equals y2 minus y1 over x2 minus x1. Wouldn't be the worst thing in the world if you just wrote down that formula every single time. So y2 minus y1 is 3 minus negative 1 over x2 minus x1. And if you need to label your points, that's always a good idea too. But if you don't need to label them, that's fine also. Not a requirement or anything. 3 minus negative 1 is going to be 3 plus 1, which is 4. 1 minus a negative 3 is 1 plus 3, which is 4. 4 over 4 is 1. So the slope here is 1. And that would just be 1 over 1, meaning up 1 to the right 1. Just be careful with the negatives there. Minus a negative 1. Minus a negative 3 becomes plus 1 and becomes plus 3. Slope-intercept form. Slope-intercept form is the form of y equals mx plus b, where m is the slope, as we just talked about, and b is the y-intercept. So we can use this form, the slope-intercept form, to generate the lines. We could just use this form to generate lines onto a graph. The b indicates our y-intercept, so that could also translate to our beginning point, the first point. And then the slope just tells us how steep it is. Is it a positive slope up to the right? Is it a negative slope down to the right? What does that line actually look like? That slope will indicate that for us. So in this first equation, number 3, find the slope and y-intercept of the equation. Y equals negative 2/3 x minus 4. So in slope-intercept form, y equals mx plus b. B is the y-intercept. So in this equation, the y-intercept would be negative 4. So the y-intercept is negative 4. So y-intercept negative 4. That's that b term. Y equals mx plus b. So minus 4. And then the slope is just that negative 2/3. So if we were to go graph this, well, it's not asking us to do that, but if we were, we would start at this y-intercept point, negative 4, and then just take the slope, negative 2/3, and go from there. We'd start at negative 4 on the y-axis, go down 2 to the right 3, down 2 to the right 3, negative slope indicates that we have this negative slope there. Number 4, find the slope, typo, and y-intercept of the line whose equation is, another typo, wow, I made a few typos here, whose equation is negative 2y equals negative 6x minus 2. So negative 2y equals negative 6x minus 2. What we want in the end form, we want this equation to be in the form y equals mx plus b. Don't look at this and say, oh, negative 2 is the y-intercept. negative 6 is the slope because it's in that mx plus b form. It's not. Look, 1y. This is not a 1y. That's a negative 2. I have to get the y by itself. I need it to say 1y equals mx plus b. So in this case, I have to divide by negative 2. So I get y equals negative 6 divided by negative 2 is positive 3x. Negative 2 divided by negative 2 is positive 1. Now I can identify the pieces of this. So slope is 3, and the y-intercept is 1, positive 1. So y-intercept of 1, slope of 3. So you have to solve for y. This next example here is a little bit more difficult because we have to solve for y, and it's not as easy. So we have 6x minus 4y equals negative 8. So the idea here is that we solve for y. So I want to get rid of that positive 6x. So that means I'm going to subtract 6x. Get negative 4y equals negative 6x minus 8. I'm going to write that as negative 6x minus 8 because I want to get it in the form of y equals mx plus b. Next, I would divide by negative 4. Get y equals, so the negative 4's cancel. That's why we divided by negative 4. Then I have negative 6 divided by negative 4. So negative over negative makes that a positive. We have the fraction 6 over 4. That simplifies. 2 goes into 6 3 times. 2 goes into 4 twice, so 3 halves. So this would simplify down to 3x over 2 plus 2. Negative 8 divided by negative 4 is positive 2. So y equals 3x over 2 plus 2. Making our slope 3 over 2. And the y-intercept positive 2. Good problem there. Good solving. It's just like solving an equation. When you're asked to solve an equation, you solve for y. It's the same exact thing. We just have those variables being thrown in there. Number 6, find the slope of the line y equals 2 and x equal to negative 1. So finding the slope of these two lines. Y is equal to 2. Y is equal to 2 is just a horizontal line at the y value of 2. So think about that. The slope of a horizontal line, it's a flat line, it's not going up, it's not going down, so the slope here is 0. We don't have a slope, it's not going up or down, it's just a flat line, so there is no slope there. Where on x equal to negative 1, let's take a look at what that looks like. X equals negative 1 is going to be a vertical line at the x value of negative 1. So what would be the slope there? Well, it's a straight up and down line, so then that means that it would be undefined. And let's just think about this from like a mathematical, like, why is this happening type of standpoint. If you take, let's go back to the blue line for a second, my y equals 2. If you take 2 points, let's say like here and here, and you're trying to calculate slope. Remember, slope is y2 minus y1 over x2 minus x1, or your change in vertical distance over your change in horizontal distance. So on my blue line, my flat line, my horizontal line, that y equals 2 line, my change in y, I'm not going up or down, right? My slope, my y2 minus y1 is going to be 0 because I'm not going up or down. It's the same y value. Where on the bottom, we do have horizontal change, regardless of what you call it, wherever you go, whatever this is, let's just call it 2. 0 over 2 is 0. So I just get 0 there because I'm not going up or down. We're on the undefined side, so if we look at the red line here, so if I go like from here to here, my change in vertical distance for my y2 minus my y1 over your x2 minus x1, if I'm not going, or if I go up or down, it doesn't matter, however many units, let's just call it 5 or 2 or 3, it doesn't matter because we could just take any point on this line from here to here or here to here, it doesn't matter. But my change in horizontal distance, my x2 minus x1, in this case, I'm not going left or right from that vertical line. So I'm dividing by 0. Whenever you divide by 0, that's undefined. So you can't divide by 0. So we don't have any change in horizontal distance. So the change in horizontal distance is 0. So it's undefined. Good couple examples there. parallel and perpendicular lines. So there's some relationships that we want to understand with parallel and perpendicular lines. So parallel lines have the same slope. Same slope. So the slopes are equal. But y-intercepts are different. So same slope, but the y-intercept is different. And think about why that is. If we have the same slope, what does that mean? That means that they're going the exact same direction. They're doing the exact same thing. But we need different y-intercepts, because if they're the same y-intercept with the same slope, think about what that looks like. It's the same line. Same slope, same y-intercept is the same line, because it's doing the exact same thing, starting at the exact same point. But if we have different y-intercepts, we have different starting points. So that's why we need different y-intercepts for parallel lines. Perpendicular lines, all we're worried about with perpendicular lines is that the slopes are negative reciprocals of one another. Slopes are negative reciprocals. And what that means is that if I have a slope, let's call it like 2/3. Or we could say, there's another way to define this that's a little bit clearer. Let's define this also as the product of the slopes equals -1. That's probably an easier way to define it. Product of the slopes are -1, which also means that the slopes are negative reciprocals of one another. So what this means is if I have a slope of like 2/3, let's say, and then I have a slope of -3/2, if I multiply these two slopes together, I get -1. Because this was -3/2. 3's cancel, 2's cancel, so I get -1. So then that means those slopes are perpendicular to one another. For lines to be perpendicular, if we have a graph, the lines will look like this. So the line would go through here, and then another line would cut through this, making a right angle. Perpendicular means at a right angle, like intersection in streets, that's a right angle. Those streets are perpendicular. Two streets that just meet at a corner like that, that's perpendicular. Parallel, if you have parallel lines, they are the same slope, different y-intercepts, so we just have parallel lines here. So perpendicular lines meet at a right angle. So in these couple examples, what we want to do is we want to identify if they're parallel, perpendicular, or neither, and we have some work to do ahead of us. What we have to do is we have to solve for y in all of these equations to compare the slopes fairly. So in the first one, I have y equals -3/4 x plus 2. Not going to do anything there. It's already solved. The second one, -4x minus 3y equals 12. So here I have to solve for y. I'm going to add 4x to both sides. And that's going to leave me with -3y equals 4x plus 12. I'm going to divide by -3. So I get y equals 4x over -3, or -4x over 3, doesn't matter, minus 4. So let's compare. Let's look at the slopes. So I have the slope of -3/4 and the slope of 4 over -3. So first of all, they're not the same, so we know it's not going to be parallel, because they're not the same. They'd have to be the exact same slope in order for them to be parallel. Now let's check for perpendicular. For them to be perpendicular, we want to multiply the slopes together. So I'm going to do -3/4 times 4/3, -4/3. And we get 3 over 3 cancels, 4 over 4 cancels. Negative times a negative makes it a +1. So in this case, they are not perpendicular because we get +1. Not perpendicular then. So that means that they are neither. Letter B. Y equals 3x plus 1. It's already in slope-intercept form. Y equals -1/3 x plus 4. So let's compare this. So first of all, parallel? No. Different slopes, so it's not going to be parallel. Now let's check for perpendicular. So I want to take the slope, so 3 times -1/3. 3 over 3 cancels, leaving me with just -1. That's what we want, for them to be perpendicular. The products equal -1, so in this case, that is perpendicular. And letter C, y equals 5 over 6x plus 1. That's already done. And then we have 6y minus 5x equal to 10. That one we have to do some work here. So I'm going to add 5x over. 6y equals 5x plus 10. Divide by 6. So we get y equals 5x over 6 plus, and then we get 10 over 6, so that's going to be 5/3 because 2 goes into 10 5 times, 2 goes into 6 3 times. Slopes are the same, 5/6, different y-intercepts though. So that means that they are parallel. So all three examples here, neither for the first one. Perpendicular for the second one, and parallel for the last one. Just got one more example here. Just a application to this. So in this graph, we have the graph showing an annual production of electric cars in thousands for year X. Find the slope of the line, attach proper units to the rate of change. So we have this electric car scenario where the X values across the X-axis are the years, and then the Y values are the production in thousands. So we want to calculate slope and get an understanding of what that means. So let's grab 2 points. They don't do a good job on this graph of like giving us some solid points. I like this point right here. So the X value is 2017 and the Y value is 100. And then I'm going to choose this point also. That looks okay. 2016. And the Y value, let's call it like 75. So here we go. I'm going to call this my X1 and this my Y1, and I call this one my X2. Y2, I kind of just went backwards. So Y2 minus Y1 over X2 minus X1. So 100 minus 25, or 75 is 25, over 2017 over 20 minus 2016 is 1. So 25 over 1. Now let's understand this. The Y values, the change in the Y values, so that means that for every year, the change in the X values are changing by 1 for 1 year, we are producing 25,000 cars, electric cars. So for every year, we are producing 25,000 electric cars. And letter B is just asking us to write a sentence. I pretty much just said it. For every year, because the X values are changing by year, the Y value is changing by thousands, and then we just calculate a slope of 25 over 1, meaning for every single year, we are producing 25,000 electric cars. Yep. So there it is. And you can write that out for letter B if you want, but I'm just going to leave it at that.